Hello, everyone. This is Lynn from HashiCorp. We are ready to get started. So thank you for joining our webinar today. It's hosted by our software engineer, Calvin Lang. Calvin has been working on Vault since its early releases and was instrumental to the release of Vault 1.0. He'll start by introducing Vault 1.0, demo cloud Auto-Unseal, and batch tokens. And take you through the journey that got us to this point. We will then spend the last 15 minutes dedicated to a live Q&A. This webinar is recorded, and the recording will be made available after post-processing, usually within a day or two. I will email it out to everybody. So feel free to put questions in the questions box, and we will answer them at the Q&A. So with that, let's go ahead and get started. Off to you, Kelvin.
Hello. Okay, I think I'm unmuted now. All right, let's get started. Cool. Welcome, everyone. Today, I'm going to talk about a couple of new features that came out in Vault 1.0. Quick intro, my name is Calvin Liang Huang, and I'm a software engineer in the Vault team. So for today's agenda, we're going to go over three things. The first one is going to be Auto-Unseal. The second one is going to be related to Auto-Unseal. It's called seal migration. And then the third one is going to be performance related, and it's about batch tokens. So let's get started with Auto-Unseal. So the typical way that we protect the master key in Vault is using the Shamir secret sharing algorithm. And in OSS before 1.0, this is the only way to protect the master key. And the way that Shamir works is that we basically split the master key into a number of key shares. And unsealing requires, or unsealing using master key requires meeting a certain number of thresholds for the keys. By default, the number of keys that were created, or the number of split keys that were created were set to 5, and the threshold was set to 3. And what this meant was that every time that Vault started up after init, we required human intervention in order to unseal Vault and proceed with, so that Vault can proceed with its normal operations. So Auto-Unseal was released in order to address this problem. It was initially released on Enterprise for use with HSM modules. And the way the Auto-Unseal works is that it gets rid of the Shamir secret sharing algorithm, and it uses the HSM module to protect the key. And this meant that there was no human intervention required when it came to unsealing Vault. So with HSM, it uses PKCS11 in order to encrypt and decrypt the master key. And we support multiple encryption mechanisms such as AES-CBC padded and unpadded, AES-GCM and RSA. And later down the road, we also introduced auto-unsealing using cloud KMS providers. We first introduced AWS KMS as our KMS provider, and then we added on GCP KMS, Azure Key Vault, and AliCloud KMS. And the way that these cloud KMS providers work is that we basically use them to encrypt the master key, and it returns us back a ciphertext. And during unseal, we make a call to exchange the ciphertext back for the plaintext master key. So there are a couple of differences between Auto-Unseal and Shamir. For one, Auto-Unseal, during that mode, we don't return back our unsealed keys to the operators. The master key is stored encrypted within Vault. And what gets returned instead are what we call a set of recovery keys. And recovery keys are used for a couple of operations that normally requires a quorum or requires the unsealed key shares. It's used to, for example, trigger an auto-unseal if we manually seal up Vault. It's also used to rekey the master key or rekey the recovery key. And it's also used for root token generation. So let's head over to our first demo. So we're going to start off with starting up our Vault server using a config file here, config.htcl. And this file contains the typical things that you'd see in a config file. It contains a couple of globals, such as our API address, the log level, our plugin directory. It also sets up console as our storage backend. And it also sets up a listener, TCP listener on port 8200 so that we can listen to requests. And then lastly, we have this seal stanza here. In this case, we're setting AWS KMS as our cloud KMS provider. Normally, under this seal stanza, we have also other AWS related parameters, such as the region, the access key, and the secret key, as well as the KMS key ID. But for the purpose of this demo, I've set them up using environment variables. So this block is empty. So let's start up our server. And we can look at the config in here, and we see that the seal type right now is AWS KMS. So let's get started with a couple of commands. The first command that we're going to run is vault status. And we get back the status saying that this server has not been initialized yet. So let's go ahead and initialize it. So when we initialize it and we get a set of recovery keys back, I've gone ahead and also set these set of keys as my environment variable. So let's go ahead and see now at the status once again. We can see that Vault, this server, has now been initialized, and it has also been automatically unsealed. So the sealed state is false. So we can test the auto-unseal by restarting the Vault server. So let's go ahead and do that. Let's restart our server and start it back up. And when we start it back up and we look at the Vault status again, normally with Shamir, it will start back up in a sealed state. But with Auto-Unseal, we can see that it comes back up unsealed. So let's manually seal this Vault server now. And then we can use our recovery keys to unseal this Vault server. So we pass in our set of recovery keys. We only need 3 in this case. So I'm passing in our recovery keys 1, 2, and 3. And on the third one, it should come back as unsealed. And we can verify that once again with the Vault status command. And that's it for our first demo. Cool. So let's go over to seal migration now. Seal migration was basically implemented alongside the porting of Auto-Unseal into OSS, because we understand that a few of our customers are already using Vault in production using Shamir, and we want to provide them with a way to migrate their clusters from Shamir to Auto-Unseal and also back if they desire, without having to start over from scratch. So one thing to note is that seal migration is currently supported in OSS due to a couple of factors, one of them being seal wrap and the other being replication. So these two basically adds complexity to the seal migration process. So for now, we're only supporting seal migration for OSS, but there are plans to also support this on the enterprise side. So let's go over to our second demo, and that is with Auto-Unseal. Seal migration. So with seal migration, we start off by using this config-shamir.htcl file. This file is pretty much similar to the first config that we saw for our first demo, but we've gone ahead and removed the seal stanza, so that it's going to use Shamir for our to protect our master key. So we start it up and we issue our second set of commands. The first command that we're going to do is a vault operator init. And within it, we get back our set of unsealed keys. I've also gone ahead and set this as environment variables as well. So we can use the unsealed keys to unseal Vault. We provide 3 of them. And then we can verify the status and make sure that it's in an unsealed state. So now let's just write an arbitrary value to this secret path and verify that we've gone ahead and written the value. So we can now go ahead and now that we have the server up and running, we can go ahead and start the migration process. We started off by first taking down the Vault server, and we update our config file. And here I already have a config pre-populated that allows us to go from Shamir to Auto-Seal. And it's pretty simple. You basically add the seal stanza in here, and we can start it back up. Okay, so it started back up. It's now sealed, and it also gives us a warning saying that it detected seal migration, and it's going to go into seal migration mode. But we have to provide the unsealed keys. So let's go ahead and do that. We provide the unseal keys using the unseal command along with the -migrate flag. So this is just a normal operation, just as if you're unsealing Vault normally. So after providing all 3 set of keys, we are now able to unseal Vault. And we can make sure that it has been unsealed by looking at the status. Cool. So now this Vault server is using Auto-Unseal. So how do we migrate back from Auto-Unseal to Shamir? The process is also pretty straightforward. We once again take down the Vault server, and then we update our config to add the disabled parameter and set it to true in the seal stanza. So let's go ahead and use this new config or the updated config. And once again, it's going to go into sealed state, and it's going to tell us that it's entering into seal migration mode and that we need to provide the keys in order for it to proceed with the migration. So we can do that. We can unseal Vault, and once again, we'll pass the migrate key, the migrate flag using the keys. And once it has been unsealed, we can see that the seal type has been switched back to Shamir. And we can verify the status by looking at both the seal type, the seal state, and and observe that we can also retrieve our secret so that and verify that the Vault server is running correctly. That's it for a second demo. And the last thing that I want to talk about today is bash tokens. Bash tokens came in because of authentication or because of problems or increased load during authentication. And that is because authentication, what happens during authentication is that we usually exchange a piece of credential that a service or an operator provides in order to obtain a Vault token so that they can start using Vault and generate dynamic secrets or fetch secrets from Vault. And this is applied to all of the service types, including those are microservice or functions as a service oriented architectures. And so as more users and services talk to Vault, the overhead of token creations can become a problem. And this puts a lot of pressure on Vault's storage backend. And the reason for that is because because of the life cycle of a token during token creation and deletion. So during creation, we actually do a couple of things. We perform 4 writes, 3 on indexes, 1 for the primary, 1 for the parent, and 1 for the accessor. And then we also do a lease write so that the Vault Expiration Manager can track and know when to revoke this token. And if we have replication enabled, we actually need to do 4 wall writes. Walls are write-ahead locks, which basically tells our secondary nodes that this token is there, so that we can replicate it down to those clusters. And then during revocation, we need to perform 4 deletes on the indexes and also on the lease write. And then this also creates an additional 4 writes and 8 wall deletes. So with replication enabled, there's at minimum 12 writes and 12 deletes that happens per token. So this is a lot of operations on our storage backend for a single token that gets created. And the way that we approach this problem is using batch tokens. And batch tokens, you can think of it as tokens with information encrypted within the token ID. So you can think of it as a job token, but it's encrypted instead of signed. And this is meant for batch jobs and single purpose and single use case scenarios. Batch tokens are not held in storage or in memory, so they require 0 writes. And because of this, they provide different guarantees in lifetime around the lifetime and persistence of these values. So this is a chart that compares service tokens and batch tokens. Batch tokens, for example, they cannot be root tokens because there's no way for us to keep track and be able to revoke them. They can't create child tokens. They cannot be renewed, and they cannot be periodic. They don't have an explicit max TTL. It always uses a fixed TTL during creation time that is specified during creation time. It has no accessors and no cubbyholes. And revoking a parent whose child is a batch token will simply make the batch token stop working. So there's no deletion that needs to occur. And any dynamic secret that gets generated if the batch token has a parent will get assigned to the parent. And one of the cool things about batch tokens is that they can be used across performance replication clusters, which service tokens cannot. And they also scale pretty much linearly with the number of performance standardized nodes that you have. So there are a couple of trade-offs, as we can see, with service tokens and batch tokens. With service tokens, you get a couple more knobs that you can toggle, but it comes at a price of 12 writes and 12 deletes per token that gets created. And with batch tokens, you sort of have those turned off, a lot of those knobs turned off by default, but it's very, very fast in terms of creation. So you can create a lot of these tokens without much penalty. So at first glance, it seems like batch tokens are not all that great because of all the limitations, but these are really acceptable trade-offs because most tokens, at least tokens created by services that are generated very, very quickly, they don't tend to create any children. So the parent entry that service tokens create is very often unneeded and unused. And then in terms of revocations, we're not able to revoke batch tokens, but for service tokens, at least those are created by services, we don't tend to revoke them manually anyways. We rely very heavily on the TTL and on the expiration manager to revoke these tokens. So we're pretty much doing the same thing with batch tokens. So there's not much downside in this regard. And there are still mechanisms to revoke leases without needing to revoke the token itself. For example, we can revoke the lease via the lease ID if we know the lease ID. And also, if the batch token has a parent service token, we can simply revoke the parent token, and that will cause all the attached leases to get revoked. So let's head over to our last demo of the day about bash tokens. And this time we'll start off a server in dev mode. And after the dev server has been started, it comes back unsealed and ready to be used. We can start off with a token creation command. We'll try creating a bash token using our root token. We can immediately see that we get an error back saying that bash tokens cannot be root tokens. And this is because we're using the root token when we first start up our server. And whenever token creation happens and we don't specify orphan, it's going to use the same policies as the authenticated token that we're using currently, which is the root token. So in this case, it's the root token, and we cannot create bash tokens with it. So let's go ahead and write a policy called admin using our policy admin .html file. This is basically a file that contains one policy, and it lets us do CRUD and list commands and also sudo under any path. So it's pretty much a a policy that lets us do almost everything. And now let's use this policy to create an admin token. And then I'm going to also store it as vault admin token for the environment variable. And I'm going to use this token to log in. So now I'm logged in using the admin token. I have the admin policy here. And using this admin token, I can now create a bash token. I'm going to also set this bash token under the environment variable vault bash token. And then I'm going to log into this bash token. And we can see that we get back our token ID back. We don't have an accessor. We have the default TTL value in here. And we also have the admin policy attached to it, since its parent is the admin token. We can look and see and verify that this is indeed a bash token because of the b dot prefix in here. So as of Vault 1.0, service tokens will have a s dot prefix attached to the token ID, and bash tokens will have b dot attached to it. So we can verify everything is fine by issuing a token lookup, and these values all look correct. And we can use this bash token to try to write to a cubbyhole. We immediately get back an error saying that cubbyhole operations are only supported by service tokens. And if we do a token creation command using a bash token, we also get back an error saying that bash tokens cannot create any more tokens. That is, they can't have any child tokens. So let's go back to our using our root token. And let's try revoking this bash token that we've created. We get back an error saying that bash tokens cannot be revoked. And the reason is because there's nothing on the vault end that is tracking this token, so they can't really be revoked. The only way is for the TTL to expire. All right, so the second thing that I want to demonstrate today is going to be generating bash tokens via auth methods. The first thing that I'm going to do is write a policy called bash using the policy-bash command, policy-bash.html file. And in this file, there's a single policy that lets us write to a KV secret path. So let's write this policy down or register it. And then we can enable our app role auth method. And the way that app role works is that it needs two pieces of information. One is the role ID, which we'll generate shortly, and the second one is the secret ID, which can be injected to, say, your service or to your machine during runtime. So with these two pieces of information, you can exchange that for for a vault token. And that's what we're going to be doing. So let's write our first role in the app role auth method called batch. We're going to attach the batch policy to any of the tokens that gets created by this app role. And we're going to set a token TTL of 60 seconds. And we specify that the type of token that we want to create with this particular role is a batch token. So now let's generate the role ID for this role. And we'll also generate a secret ID. And if we were to exchange these two pieces of information to Vault, we'll get back a Vault token. And this is what I'm doing. I'm just issuing a login command using the role ID and the secret ID. And then setting the Vault token that I get back to Vault batch token. And now I can do a lookup on this token that I've created. I can see that it is a batch token. It doesn't have an accessor. It was created a moment ago, and it has the batch policy attached to it. So now let's use this batch token to write a secret to the KV, to our path that we're allowed to write to. And we can use also this batch token to verify that the secret has been written. And now we can watch this token via token lookup. And we can see that this token only has 13, 12, 10 more seconds to live before it gets revoked or before it's invalid. So we'll wait for that. And once it's invalid, we'll see that we can no longer make a token lookup request. And if we do a KV get on this secret /batch/foo path that we've just written into, we get a permission denied. And that is because this token is no longer valid. That's it for batch tokens. So these are three of the new features that were introduced in Vault 1.0, but there are many more additional features that were also introduced. And these are GCP, the GCP KMS secrets engine, open API support, which is really cool, the Vault agent extension, and then now that we enable auto-auth via app role. And there's also the Kubernetes projected service account tokens. And in the UI, we added response wrapping. And in addition to all these features, there are many, many more improvements that we've also included in our 1.0 release. So feel free to try it out. And that's all I got for you guys today. Thank you.
Awesome. Thanks, Kelvin. So we've got a couple of questions from the audience. We actually got a lot of questions from the audience. So the first question is there also support for credentials through instance profile rather than environment variables?
Can you repeat that question again? Sorry.
Yeah, the question is there also support for credentials through instance profiles rather than environment variables?
Yes. So Vault's going to automatically detect. It's going to try to get the credentials via instance profile if those values are not provided. So there's an order of preference in terms of what it's trying to get, at least for AWS KMS. So yes, you can use instance profiles to provide those values.
Cool. After manually sealing the vault, would restarting the vault server unseal it automatically?
Yes, with Auto-Unseal enabled, it's going to attempt to Auto-Unseal on every Vault startup. So yes.
Okay, the next question is, during Auto-Unseal, if you manually seal Vault and you restart the Vault process, does it remain sealed or is it Auto-Unsealed?
Yeah, so it's pretty much similar to the question that came before this, and it will come back up as unsealed.
Great. So the next question is, why do we need to use recovery keys to unseal the vault? As long as we restart the vault service, shouldn't the vault be auto-unsealed?
Yes, that is correct. You technically don't need the recovery keys when it comes to unsealing Vault. We just provide this as an alternative way to unseal Vault if you don't want to restart your server. But you're correct. You can perfectly restart your server by unseal Vault by restarting your server. However, like the unseal keys are still used for other things such as rekeying and generating tokens. So we'll still have to return those for those operations.
Great. Next question is, if we use Shamir on Enterprise right now, is there no migration path to auto-unseal?
Yeah, unfortunately, that is correct. There's no way to migrate yet for our enterprise customers. If you're going from Shamir to Auto-Unseal, and that is because we tried that during our dev cycle, and it generated a lot of issues with regards to how we handle seal wrapping, since that's supported on enterprise and that involves using the KMS or HSM in order to seal wrap those values. So we do plan on adding that feature, but as of 1.0, it's not in there yet.
Okay, great. I do want to preface to everybody that Auto-Unseal was an enterprise feature, but with Vault 1.0, we are moving it to open source, so you can now use it to open source. There are a couple questions that came in asking about that, so I just wanted to clarify that real quick. And also seal migration is also an open source feature, so not unique to enterprise. Awesome. So interesting question here. Isn't auto-unseal considered bad practice?
So
putting Kelvin on the spot.
So so clearly there are a couple compromises that you have to do when it comes to auto-unsealing. You have to basically you have to understand that Vault's going to come up unsealed. It doesn't mean that you don't protect your instance. So the way that you guard against that is basically not allowing any other users to restart the service so that it can come back up unsealed. But you can still manually seal Vault as a break glass mechanism. If you see that your credentials has been leaked and you need to seal Vault, you still can do that. But the way to protect auto-unseal from auto-unsealing is to prevent a service restart.
Okay. There's actually a follow-up question to a question you just answered, which is about the restarting aspect of it. So it was like, is there not a security concern for unsealing via restarting the process after a manual seal?
Yeah, so there's definitely that. But that's one of the trade-offs that basically happens when you use Auto-Unseal.
Okay. The other question is, can you explain the interaction with cloud and security around the Auto-Unseal process?
Yeah, so we assume that if you're using the Cloud KMS providers to Auto-Unseal, that you're trusting that particular cloud provider, since it's using their own mechanism on their backend or their API in order to unseal. So there are a couple of assumptions that needs to be made, I guess, if you're using non-HSM, you're using cloud providers. We basically assume that you are at that point trusting the cloud provider in some sense.
Cool. And there are a couple of questions about slides being made available after the webinar. Slides will be made available, and we'll also send out a recording as well. I know a couple of you wanted a PDF. We'll see if we can do that. It'll be on our resources page. I'll send out an email afterwards. So the next question is token type parameter valid for all auth methods like user pass and GitHub?
So I'm not entirely sure on this one. I don't know if Vishal can answer it. I know like for the demo, batch token type was available for April, but I'm not entirely sure for the other ones.
I can answer that question. Hi, this is Vishal. The batch token configuration can be tuned on the mount. So on the mount, we can set what type of default token should be issued. Now the regular tokens which Vault used to issue all these days are called service tokens. They can always be issued, but they can be switched to batch on the mount tuning configuration.
Great. Can you migrate from Auto-Unseal to Shamir in Enterprise?
So unfortunately, the seal migration feature is not available in Enterprise, and that includes migrating from Auto-Unseal to Shamir.
Great. Next question is, in AWS KMS, is the unseal key stored as encrypted?
Yeah, so the unseal key, the master key is stored encrypted within Vault, so that value is not stored in the cloud. We simply use the KMS provider to encrypt that key, but it is stored within Vault itself.
Okay. Next question is, what are the pros and cons of Auto-Unseal versus the two-man rule? I don't know what the two-man rule is.
So I assume that is the that's with Shamir. So what Auto-Unseal brings us is that we sort of push the trust from humans and into our unseal mechanism. So with HSMs, for example, there's some echo going on. With HSM, for example, we basically push that trust into our HSM module. And what this brings us also is the ability to unseal without human intervention.
Okay. Next question is there any Auto-Unseal method for on-prem in the making? If not from HashiCorp, are there methods that are easily pluggable?
All right, can you repeat that question?
Is there any Auto-Unseal method for on-prem in the making? If not from HashiCorp, are there other methods that are easily pluggable?
Does this refer to Auto-Unseal?
I believe they're asking for people with on-prem infrastructures, is there any Auto-Unseal method?
I see.
And if there isn't,
Right.
are there any other methods that can plug
Yeah,
in?
so on-prem, the way to enable Auto-Unseal would be to use HSM, and that is a enterprise feature that we provide. So you can be completely off the grid and off the cloud by using HSM modules along with Auto-Unseal.
Great. Sorry about that echo. Some of you mentioned that there is an echo. It's because I did not mute myself. So the next question is, you mentioned that the master key is not returned to the operator, but it's saved inside Vault and returns recovery keys instead. My understanding was that the master key doesn't save and shouldn't save it. Can you explain more?
Yeah, so with Auto-Unseal enabled, what happens is that the master key is not split using Shamir. Instead, it remains as the master key. And what we do with that master key is that we wrap it or we encrypt it using either the HSM or the Cloud KMS provider. Once that's encrypted, we need to somehow store it so that it's able to fetch it during unseal and decrypt and do the Auto-Unseal. But it is stored within Vault.
Okay. Regarding the on-premise question, the person that asked the question was hoping you'd repeat the answer. He didn't quite hear.
The on-prem? Okay, yeah. With on-prem, you have the option of using Auto-Unseal if you use HSMs. So you don't have to use the cloud KMS providers. You can use HSM along with your Vault installation in order to do auto-unsealing.
Okay. And as a follow-up to the master key question that you just answered, he asks, can you encrypt the recovery keys in the same way that you could the key shares?
Yeah, so the recovery keys, they go through the same deal as if they were unsealed keys, and that is they get Shamir splitted. So you get back a set of split Shamir key shares for the recovery keys. And for any operations that require a quorum, we basically verify by putting those key shares back together and making sure that it meets the threshold and before it proceeds with the other operations.
Great. There's a question on just verbiage, I think. So someone asked, I wonder why you say something stored in Vault, in quote, the storage backend is untrusted and outside the cryptographic seal. Why do you refer to this as in Vault?
So it is stored in the storage, but it's not. It is cryptographic. It goes through the barrier, so it is encrypted. It goes through. Well, it doesn't go through the barrier, but it goes through the encryption mechanism either by the HSM or the cloud KMS provider. So it is stored encrypted at rest.
Okay, great. Next question is, if KMS auto-unseal is used and the KMS key is deleted later on, can the recovery keys be used to auto-unseal?
Yeah, that's a great question. So recovery keys are simply used to verify that the right operators are issuing the unseal command. The recovery keys themselves, they're not used for the auto-unseal process internally. Internally, we still require the underlying talking to the underlying cloud KMS provider or the HSM module in order to decrypt the master key that has been stored and unseal Vault. So if we're not able to decrypt that master key, we cannot unseal Vault, even if you have all the required recovery keys required to meet the threshold.
Great. Next question is, can I auto-unseal using Azure and Google and AWS or only one of them?
So it is only one of them. You specify there can be only one seal stanza, and you need to specify which one you want to use.
Great. The next question is the HSM auto-unseal using PKCS11 still available only in the licensed version, or is it now open sourced?
Yeah, so the only thing that was not open source is the HSM for auto-unsealing using HSM. So that remains to be an enterprise feature. All the other ones that are cloud that uses cloud providers are open source.
Great. The next question is, what happens to Shamir keys when we migrate to auto-unseal?
Great question. Yeah, I should have mentioned that, but I left it out in the demo. So the unsealed keys, they become the recovery keys when the seal migration happens. So if you start up your Vault server with a set of unsealed keys returned, those unsealed keys can be still used for all the operations that normally requires using unsealed keys, but now they're treated as recovery keys. And then if you're migrating back from auto-unseal to using Shamir, those recovery keys gets turned into the unsealed keys. Yeah.
Great. Next question is, if HSM is not accessible, can we use recovery keys to unseal the vault instead of using auto-unseal?
So I think this question a similar question came in, and that is the answer is no. You would still need to be able to talk to the cloud provider, to the cloud KMS provider, in order to unseal Vault. So just with the recovery keys alone, it's not enough, because the recovery keys, as I said before, is simply used to verify that the right people are using are able to unseal. But the actual unseal mechanism still needs the master key, which is encrypted by the either the HSM or the cloud KMS provider.
And just final two questions before we wrap up. Can you configure the number of recovery keys and the threshold within Auto-Unseal?
Yes, so you can either configure it during init by specifying the I think it's called recovery key shares and recovery keys threshold, or recovery shares recovery threshold, and you can also do it with every key. So if you started off with one, or however many, you can simply issue a rekey and provide the new key shares and new threshold that you want to use.
Great. Someone asked, this is probably a little bit unrelated, but is multi-data center application enterprise-only feature? And I just want to iterate that it is still an enterprise feature. Great. Next question is, and last question, what is an appropriate use case for batch tokens versus service tokens?
Yeah, so batch tokens comes in really handy when you have a lot of short-lived services or Lambda functions, let's say, that hits Vault very, very constantly. So that's when batch tokens comes in handy, because you reduce the load on the server, both in terms of hitting the storage backend and in Vault itself by a lot. Well, maybe not in Vault itself. It still needs to make the request, but as far as the storage backend goes, it goes from 12 writes to basically 0 writes, unless there are writes involved within the auth methods itself. But it reduces the writes and deletes by a huge amount. So as far as our internal testing goes, we've seen that it pretty much scales up linearly now with the number of performance secondary nodes that you put in. So the more performance secondary nodes you have, the more requests you can serve using batch token, which is not the case with service tokens, because that is bottlenecked by token creation. So for jobs that are fairly short-lived and that are constant, batch token is basically the perfect type of token to use.
Great. At this point, we are going to wrap up. So I just want to thank everyone that submitted questions. There's some really great questions, and Kelvin for answering a lot of them. I hope you enjoyed today's webinar, and as I mentioned, we will be sending out the recording. If you would like more webinars, you can visit our website, hashicorp.com/events. We actually have a Terraform 0.12 one tomorrow, and then a Consul Kubernetes one on Wednesday. So that's it, and we'll send an email out to everyone with the recording and slides after, and I hope you have a good Monday.